Okay, so after we create the ASC, we now need to create an ability. Let's go to our ability system. We haven't covered attributes yet. We'll first guide everyone through implementing the first ability. I think if we started with attributes, the cycle would be a bit too long. So the plan is like this. We'll prepare an ability. An ability is an abstract concept. It can depend on what you want to do. How to implement it? Let's first write a very simple ability. Okay, so how do we define an ability? Everyone has played games, right? In games, there are actually all kinds of abilities, and passive abilities, active skills, two-stage skills, and such. It's pretty much the same concept. Let's first write one here. First, inherit the ability class. Okay. Then, we need to declare this forward declaration here, because we might use these things later. Then here we implement the class. So how is this class written? It just needs to inherit from GameplayAbility. After we finish inheriting, don't write any code yet. This comment means it is used by our project. This is the basic class. That's what it means. Then we instantiate it. Then we call the parent class's parameters. Okay. Alright, now let's try to compile. First, let the team members compile it successfully. Okay, this gives an error. Let's add this semicolon. Okay, let's take a look at this again ability. This is our skill. We usually call it GA. So it actually defines the logic of this gameplay, and it can be activated by the player or activated by other places. So this is a very important piece of comment. So this comment tells you that an ability activates some processes. Then it will definitely check whether this ability can be activated. Then it will try to activate this ability. When trying to activate this ability, it will perform some complex checks. If it can try to activate, then it will actually activate this ability. And then submit this ability to perform corresponding calculations and so on. And this part is how these methods are used and triggered. So everyone can take a look. Just try it literally when we use it later. Okay, so let's come back to this next. It means we now have this general capability. Within this general capability, in its constructor function, we need to write some methods. We need to define some properties. First of all, we need to modify its gameplay ability's repractic, a master's degree. Let's modify it. Yes, this ability, whether it will sync these stats event to everyone on the world. Actually, if you select none, that is, we will not synchronize this abilities instance to anyone. So replicate, yes, that is, we will synchronize this abilities to its owner, this one place. Okay, and then in this place, we have here a strategy called instant. This instant strategy means that this ability, when it executes, depends on how to instantiate it right. Obviously, this is not instantiating. Each actor instantiates such an ability. Right, and this is equivalent to each time it executes, instantiating this ability. And when it is instantiated differently, doing this network replay, there are certain limitations to make it based on this actor. To do this in some portion. And the most important thing is actually this. This is the execution strategy. It defines it, this ability, how it is executed, then this is client-side prediction. This only allows the client to execute. This is initialized by the server. Then worry that if there is a client, it will also allow the client to execute, and this only allows it to run on the server. Yes. Okay. Then let's take a look next. Then this is its write policies. It essentially means it is to define this how it is executed and terminated. Such a protection strategy for termination. Obviously, the first case ignores it. That is the server and the client. They can both trigger the execution and termination of this ability, and this saver only expression means that if the client requests to execute this ability, it may be ignored by the server, but the server can request the server to cancel it or end this ability. And saver automation means if this client requests to cancel or end this ability, it will be ignored and only. But the client can still request to execute this ability, and sail only means all aspects of this ability. It only allows it to be done on the client side and on. No, wrong. To do it on the server side and the client, any request it makes will be ignored. Okay, so at this point, everyone might still be a bit confused about these concepts. When we write later, everyone can manually modify them to trigger these concepts and see the different results after. Then everyone will have a general impression. Okay, let's set these things to their defaults first. Okay, now that we have this general capability, we need to write some more methods. These methods are quite simple because we need to use this capability to obtain the corresponding components. For example, sometimes we might need to get this ASC. Sometimes we might need to get the player controller. Because it must be this punk, that is, this character, only it has this ability. So once you have this punk, then you can get its controller and the corresponding information about its character. So first, how to get the ability system. Actually, we can get it through this code because there is a query info here. It is in our parent class and it records some related information about this actor. Then here in the query info, we directly go to take it like this ability system, whether it exists. If so, we will take it. After obtaining it, just cast it. Look, it is here. You will find that is query info. It is this structure. This structure is here. It will have these avatar actor, player control, ability system, sketch component. I mean, it will help you during its execution. It will provide you with so much info, so you don't need to worry. This half you can smoothly, after obtaining it, convert it into the ask we want. And it's done. And note that the controller here may need to include the corresponding header file. Let's just include it here. Otherwise, it will keep showing red. Then next, we get our controller. So obviously, we also use this. It should be this XG player controller. It should be this one. This is written in the wrong place. It should be written here. Here we get the ASC. Here we get our controller. It's the same. Get this controller. Just convert. Then next, it mainly takes this controller because it could be this. Could be this computer's controller. So what is returned here is a computer's controller. First, we need to trigger whether your arca_info class exists. If it exists, we first check whether we can get the player controller because we may not have this player controller. If it is an AI, then at this point we recursively, that is loop through it. And then here we get this pointer. The minute hit is actually to see if we can successfully convert this D and also get it. If the conversion is successful, we return it. If it still doesn't work in the end, we just give it a null pointer. Here it is converting it to see if it is a controller or some PAM and such. That's basically what it means. And then finally, actually take our actor. We just need to take this avatar actor and convert it. You can see this chain here. It's actually a bit messy. We can click here like this, and then we can see, you can see this is the shared cache information. It's about some status information on the player that is often used. And this owned actor is our ASC. Is this actor who used this ability? It should not be empty. This alert actor is the one that actually executes it. This could be empty. Yes, that's roughly the idea. This is our ASC. Okay, good. Let's compile it. Make sure it compiles successfully. Good. Since we're talking about this character info, so this character info, how exactly does it come about? So let's go back to our character base. Back to our character base. Now we need to redo two methods. Then we'll write it. We'll write it at this position. We'll write it here. We need to do a lot of this kind of work. So this is our begin play and our underplay method. First of all, we still need to call the super, okay? After you call this super, we can then proceed further. If there is no super, there will be a problem. And pay attention, our initialization, we need to initialize now RASC component. Then this component, it must only be initialized on the server. So this component, it must exist. It must exist. It must exist. After it exists, we execute this method for it, called untabulate doctor info. Then here we will pass in own doctor and avatar actor, right? Then an initialization of information will take place here. Then it will cache this information for us here. Okay, we can take a look at this comment. You can see this is initializing the abilities actor info. This struct will hold the information, that is who we are playing as, and who controls us. So this is the owned actor. It is usually the component that logically owns this. And the what actor, in fact, refers to this entity. The entity we control. It is usually a character, but it could also be a defense tower. It could also be a building, or it could be other things like that. Right, so we'll keep it here. We place an ASC here so that everyone can. Don't let everyone confuse these two concepts and make them hard to understand. Here, it refers to the player's hero. In fact, many times when we design, we ourselves might be a player controller, and the player controller drives a hero, like in RTS games and similar situations. Then these two things are definitely different. In this project, they're the same. So, this point needs to be specifically emphasized to everyone. Actually, at this point, we have basically finished creating our ASC component, and it has been registered. At the same time, we have also defined the basic gaming ability